In this theory, I am going to introduce various theories of light. The first up, the first thing is, what is the light? If a layman asks you what is light, simple answer to this is light is a form of energy which we can see. That is light. But how this light travel, from one place to another? We can't see it. How it travel? Does it has legs? Then how it walks from one place to another? We can't see that. When we can't see the things, what physicists do, they propose different theories. So the first theory proposed, name of which is corpuscular theory of light. Corpuscular theory of light. And this theory of light was proposed by Dutch scientist named Descartes in 1637. But it was developed by Newton in his famous book named Optics. And this book was very popular in those days, and so this corpuscular theory of light is attributed to Newton and not Descartes. According to this theory, the light consists particles, or you can say light consists corpuscles. So corpuscles are particles, and by elastic collision, light travel from one place to another place. According to this theory, light consists particles, and there would be elastic collisions, and by that elastic collisions, the different particles travel at different directions. Now we know that light consists different colors. According to this theory, the particle size is different for different colors. Using this theory, Snell's law is derived, as well as laws of reflection and refraction explained. So using this theory, you can explain laws of reflection and refraction. But there is a one drawback of this theory. Drawback of this theory is this theory failed to explain interference and diffraction. So this is the biggest drawback of this theory. We can't, based on this theory, we can't explain the phenomena such as interference and diffraction. The second theory of the light is wave theory of light, which was, the proposed by the scientist Huygens. In 1678. In this year, the wave theory of light is proposed by the scientist Huygens. For this theory, medium is required. So, Huygens proposed that this universe is filled with hypothetical medium, which he called ether. Then, according to this theory, by way of vibrations, light goes from one place to another. By way of vibrations of the particles of the medium, light travels from one place to other. That is, for example, if this is the source of light, and according to this wave theory of light, this source is surrounded by particles of the medium called ether. Let's assume that light is propagating in this direction, and we will consider here three particles. Suppose this is 1, 2, and 3. Let's name them A, B, and C. So these are the three particles along this direction of propagation of light. Then what happens here? The particle A is very close to the source S. So it gets first stimulations and it starts vibrating in a direction perpendicular to the direction of propagation of light. Now particle A is linked with particle B. So particle B also start vibrating in the same direction. Then particle C is linked to particle B. So particle C starts vibrating in a direction perpendicular to the direction of propagation of light. So by this way, by way of vibrations of the particles of the medium, light propagates. This is the wave theory of light. But this theory of light was not accepted till 1801. It was not accepted because in those days Newton was very big name. Nobody wanted to contradict him. So this theory, wave theory of light, was not accepted until 1801. What happened in 1801 is that another scientist named Thomas Young, he did double slit experiment, and theoretically and experimentally proved that wave theory of light is correct. And so, in next 40 years, various phenomena of light were explained on the basis of wave theory of light. So, in the middle of 19th century, the wave theory of light was well established. But this theory also has drawback, and the drawback is the medium. Medium is required. However, it was observed that light travels through vacuum also. So that is the drawback. Then in the year what happened in 1865, another scientist, Maxwell, was developing set of equations for describing laws of electricity and magnetism. There were various laws for electricity and magnetism, and Maxwell was trying to unify these laws, such as Gauss law. Then second law is no magnetic monopole law. Third law is Faraday's law. And the fourth law is Ampere's law. So these are the laws of electricity and magnetism. So what Maxwell was unifying this electric and magnetic phenomena, and he developed a new phenomena. He unified these laws. For example, he combined Faraday's law and Ampere's law and developed a new equation by combining Faraday's law and Ampere's law. He developed new equation which is wave equation. And using this wave equation, he found velocity. Velocity of that wave. Theoretically, he found velocity of that wave, and that velocity of the wave was very close to velocity of light. And hence, he proposed that light waves are electromagnetic waves. According to Maxwell, light waves are electromagnetic waves. And how these electromagnetic waves propagate? What happens there? Changing electric field produces time and space varying magnetic field. And changing magnetic field produces time and space varying electric field. So changing electric and magnetic field results in propagation of this electromagnetic waves. What happens, if there is a changing in electric field in perpendicular direction, we get varying magnetic field. Now this varying magnetic field produces changing electric field. And this way, by changing the electric field and magnetic field, results in propagation of electromagnetic waves. So, according to Maxwell, light waves are electromagnetic waves. But this theory also has drawback. This theory couldn't explain, or this theory failed to explain Photoelectric effect. You know what is the photoelectric effect? When light fall on photosensitive materials, electrons are emitted. So this phenomena, that is a photoelectric effect, couldn't be explained using electromagnetic theory of light. Then in the year 1900, the Max Planck, another scientist, was studying black body radiation. He developed some equation, and that result of that derivation was not satisfying if he assumed light is the continuous wave. So just not a intellectual thing, but just to fit that formula, he proposed that light is not a continuous phenomena. On the contrary, he says that light source emit quanta, discrete quanta. According to him, light source emit discrete quanta called photons. That is, light source emit energy packet. If there is a source here, then light source emit discrete energy packets. And each packet is having energy h nu. H is the Planck constant. And these energy packets are nothing but photons. And so this is a particle. So we started with the particle theory, then wave theory. Again we came back to particle theory of light. Now based on this, by assuming that light consists of photons, discrete photons, in 1905 Einstein explained photoelectric effect, for which he got Nobel Prize. So some of the phenomena can be explained on the basis of particle theory of light. Others phenomena are explained on the basis of wave theory of light. So to combine these two phenomena, in 1924, de Broglie proposed dual nature of light. That is, light has both the natures, particle nature as well as wave nature. And to combine these two natures by the equation lambda is equals to h upon p. Lambda is the wavelength, which is the wave nature. P is the momentum, that is mass into velocity, that is a particle nature. So wave nature and particle nature are related by this equation lambda is equals to h by p. The modern concept of light consists both the natures now, Newton's as well as Huygens' description of light. We are going to study the two phenomena here, interference and diffraction, and in these two phenomena we are considering light is having wave nature.